Greetings everyone! Today we're going to explore the operations of real numbers. Today's foldable looks like this. If you didn't get it in class, it is available on Google Classroom, or as always, you can take notes in your own notebook. To start off, let's talk about addition. Now, a lot of you will be familiar with these rules. So if the options I'm providing aren't making sense because you understand it another way, that's completely fine. What we do need to work on altogether is that we can perform these operations without a calculator. So in the addition box, it says adding signed numbers and examples. In the top half of this box, when adding numbers with the same sign, you add the numbers and keep the sign. So a positive plus a positive is a positive, a negative plus a negative is a negative. Let's go to the right and jot down some examples. Remember, at any point, if you need to pause the video, please do so. Here's an example of a positive plus a positive, and here's an example of a negative plus a negative. Keep in mind that there happens to be parentheses on this, but I'm guessing you won't always use parentheses, and you don't need to. This would also be an okay way to write that example. Let's talk about adding with different signs. When you're adding with different signs, you subtract the numbers and take the sign of the bigger number. Another way to remember it, if it's different signs, you find the difference and keep the bigger sign. Let's take a look at some examples to clarify this. 15 and 10 have a difference of 5. The 15's bigger and it's negative, so my answer is negative. Now, if you visualize a number line for this, let's say you're like, oh, I'm at negative 15, I go to the right 10, and I land on negative 5, completely fine. That is okay to visualize. If you have another trick or another way to remember these rules, stick with it. Here's another example. If I have negative 15 and positive 25, the difference between those two numbers is 10. The larger number's positive, so it stays positive. If we take a look at this one, 5 plus negative 8. The difference between the numbers is 3. The 8 is larger and it's negative, so my answer is negative. Again, if you didn't get a chance to write that all down, go back and pause the video. Let's jump to the subtraction rules. In the top half, let's write, to subtract signed numbers, you add the opposite. Let's see what we mean here. What that means is we're going to change all subtracting problems to adding problems, because adding tends to be easier. So some steps to do that. Step 1, keep the first number. Step 2, change the sign. Step 3, change the sign of the number. And then step 4, you could just write add, because we just created an addition problem. So you might have heard from a previous teacher the idea of keep, change, change. You might also, again, still think of the number line. The downside is when we have those double negatives, it's kind of hard to think of a number line. So let's take a look at some examples to clarify this. So I have negative 8, subtract negative 2, right? Some of you might be comfortable, a side note, you might know that double negatives become positive, and then you just have that memorized and you go from there. If you don't know, here's how this works. Step 1, keep the first number as is. Step 2, change the subtraction to addition. Step 3, change the sign of the second number. So instead of -2, it's now a +2. That creates an addition problem. So when I add different signed numbers, remember the rule, the difference between 8 and 2 is 6. The larger number is negative, so we make our answer negative. Let's look at this one, 4 minus 7. Again, if your brain thinks number line 4, go left 7, -3, that's fine. This is another option. Keep, change, change. Keep the first number. Change the subtraction to addition. Change the sign of the second number. If it was a +7, it's now a -7. Now it's an addition problem. The difference between 4 and 7 is 3, and the larger number's negative. Let's take a look at multiplying. Multiplying rules, for some reason, we tend to remember these a little bit better, so we're going to fill in our parentheses there first. For example, a positive times a positive, always a positive. That's the easy one. You guys already know this. An example to the left would be 3 times 2 is 6, right? Everything's positive, good to go. A negative times a negative is a positive. For example, -3 times -3 is +9. When the signs are different, like a negative times a positive, it's negative. -10 times 4 is -40. And if I flip those, because we've learned about the commutative property of multiplication, if it's the positive then the negative, still negative, right? The answer stays the same if I flip. So an example could be 8 times -3, -24. So these rules here, notice the pattern. 4 rules, 2 are positives, 2 are negatives. The ones that are the same are always positive. The ones that are different are always negative. This is something we need to memorize. Okay, we need to know these rules. With adding and subtracting, there's other ways to visualize or figure it out. But with multiplying, you have to remember them. Let's take a look at dividing. The nice thing about dividing, it's nothing new. It's exactly the same as multiplying. So when we look at those symbols, I'm going to fill up everything so you can jot it down. All the signed number rules are the same. So some examples are provided to you. I'd recommend pausing and filling this out. A couple of reminders, don't forget that if we have anything times 0, it's 0. And I just want to refresh your memory because it doesn't matter if this is positive or negative or a fraction or a rational, it's still 0. Okay, so don't forget. One other thing that we may have briefly talked about in class is the rule of dividing by 0. 0 divided by any number is always 0. Okay, now if you have a calculator, that'll help you remember, but we're not always going to have a calculator allowed. So my trick for this that I learned from a friend is to say if it's an okay fraction, it's okay to have a 0. Let's look at the opposite. What if the 0 is on bottom? Then we have to say, your calculator will give you an error, can't divide by 0. We're going to write the word undefined. That's the math word for it is not possible to divide by 0. My shortcut for that, my trick that I learned from a friend, if it's a no equation, it's undefined. For fun, if we haven't already in class, make sure to ask Siri what 0 divided by 0 is sometime. All right, let's go through some practice here quick. Don't need to write these down unless you need them, but here I'm adding different signed numbers. The difference between 12 and 7 is 5, the larger number's negative. The difference between 18 and 2, oh, wait a second, these are the same sign. That means we just get to add them and keep the sign. Same sign, add them, keep the sign. Oop, different here. The distance between 9 and 11 is 2. The larger numbers, negative. The distance between 11 and 9 is 2. And the larger numbers, negative. Compare those two examples. See how its addition just flipped? That's our commutative property of addition, right? Let's take a look at a few more. Some subtraction here. I'm going to try the keep, change, change. If you want to try something else, go for it. Keep the first number, change the sign of the second number. Now it's an addition problem. The difference between 8 and 13 is 5, and the larger number is positive. Example 2, keep the first one, change the symbol, change the sign. The difference between 6 and 12 is 6, and the larger number's positive. If you don't need a special rule, don't use a special rule, right? If you know it without any rules because you have it memorized or figured another way, take care of that. 6 minus 10, keep, change, change. Difference between 6 and 10 is 4, and the larger number's negative. Another way should be, if I'm at 6 and I go left 10 jumps, right? If you're a visual learner, you'd arrive at negative 4. That's okay to think of it that way too. Multiplying. Different signs, stay negative. Same signs, stay positive. Same signs, stay positive. Different signs, stay negative. Dividing has the same rules. Same signs, positive. Different signs, negative. Different signs, negative. Ooh, this is an okay one, so it's 0. Different signs, negative. Ooh, this is a special one. It's a no, so it's undefined. All right, for today's practice, make sure that you check Google Classroom as always, see what your task is, what do we need to finish. If you have questions, make sure to ask. If you're still struggling, try re-listening to a couple of these slides without writing. Sometimes we're distracted by writing, so maybe take another listen. If you have any questions, let me know. And until next time, have a good one.